everyone. It's great to have you all here. We are so happy to see you all join us today. So today we have Mr. Tom Kerber, who you can see on the screen as well. And we have a very special guest today. Her name is Dr. Sonia Aykroyd. And we are so excited to share more about the numerous benefits and health applications of PBM. So for those of you who have reached out to us with questions via email, we really appreciate your continued patience as we respond to each of your inquiries. During our presentation today, I'll provide you with a brief bio of Mr. Kerber and the mission and vision of SunPower LED before we discuss the topic of today. And we will have a very, as I mentioned before, a very special guest, Dr. Sonia Aykroyd. She'll be commenting on PBM and its numerous applications through a presentation that she will gladly share with you. Immediately after she speaks, we will have a brief Q&A in which you can ask your questions as pertaining to the topics that she had discussed. Then we're going to continue to look at briefly about how light affects the body and a brief description of our product line, highlighting the key differentiating factors between each product, as well as what makes us different from anything else on the market. Then we're going to open up the floor to some more question and answers that guys might have as it pertains to the products. If you already have a product, if it's helping you, or kind of different applications of how you can utilize it, or any questions you have for Dr. Aykroyd, we're welcome to hearing all of it. Note that if everyone stays to the end, we will be conducting a draw right at the end, and you'll have an opportunity to win a free Palm Ultimate that has a value of $2,200 US, which is amazing. And I can't wait for somebody to, really start utilizing this to help expedite their healing. It's a fantastic product. So we would also like to remind you that we are offering promotions that will be valid only until 12 p.m. midnight on this coming Monday. For attending this seminar, everyone that is here, you'll receive $100 off site-wide off of any purchase by entering in the promo code 100. So we're also continuing to offer and provide everyone with options to pay in 3 installments. And the next webinar will be on Saturday, February 18th, 2022. And here's a little bit more on Dr. Sonia. So she is a dentist, researcher, and international speaker on lasers and photobiomodulation. She has 36 years of international work experience in Brazil, UK, and USA. She is the front runner on lasers and photobiomodulation in dentistry in the UK in 1990 and in Brazil in 1996. She's a PhD candidate. She has her degree from Eastman Dental Institute in the UK. She is laser board certified by the Brazilian Federal Dental Council, Texas laser license and certifications in various laser aesthetic procedures. She is also on the ADA committee working group for the development of ANSI/ADA and ISO standards for dental lasers. That's huge. She is the president of the Lasers and Biophotonics Scientific Group, AIDR, Top 100 World Doctors in Dentistry Award in 2020. She's the CEO and founder of Visage Laser Institute in Dallas and the clinical director at Elite Beauty Med Spa in Dallas, Texas as well. The list continues on and on. She is a bright star and light in this industry, and we are so honored to have her on. So thank you so much. And this is a quick bio of Mr. Kerber. Tom Kerber is president of Kerber USA Incorporated, which is a new company located in Buffalo, New York, that is devoted to the usage of light in medical applications. Kerber USA has been FDA registered to be able to sell PBM devices in the USA. Tom is also president of Kerber Applied Research Incorporated, which is a research and development company in Ontario, Canada, which is a short drive from Kerber USA. He is also the founder and CTO of another company called the Genesis Health Light. This company markets a powerful and patented PBM technology that was invented by Tom over 14 years ago. So he believes that he is being given a gift to be able to create devices that can be used for the greater good of humanity. Tom is a prolific inventor, having a few US patents, Canadian patents, with many more on the way in the area of medical devices utilizing light. He really has gone above and beyond to help people with pain and inflammation over the years with his new development of PPM devices. So the vision and mission of SunPower LED itself is to provide healing technologies to all nations of the world. And the company itself is committed to pushing technological boundaries with light-based devices to improve health overall. And I've seen it happen over and over and over again. It is very powerful, and it can really help expedite individuals' healings and catalyze certain processes in the body that help to make your healing journey that much better and easier for you. So now I'd love to bring Tom back on, and he's going to introduce Sonia on very briefly, and they're going to take the show away. So ask all of your questions and make sure to stay to the end. And you can also ask all of your questions in the chat box, and we'll answer everything you guys have. So thank you so much once again for joining us. We appreciate your time, and take it away, Tom.
Thank you, Dr. Aykroyd, for coming on.
Thank you so much. Thank you, Michaela, and thank you, Tom, for inviting me, and thank you for the nice introduction. Today, I would like to talk about some aspects of photobiomodulation and keep this very practical. So let me try and share a screen with you. Can you all see it?
Yes, we can see it.
Yes. I'm just going to guess yes and go ahead. So I would like to talk about the practical side. There are lots, of course, you can diving into mechanism of action, but all the research is out there, and so much already being published on how lasers and biophotonics in all spectrums of it can be influencing the biological tissue. So I'll keep my title as photobiomodulation therapy in clinical practice. But before we start here, diving into it, I would like to talk a bit about the importance of light in health. As early as 1903, Dr. Niels Finsen, a physician scientist, had already received a Nobel Prize for using concentrated light irradiation to treat diseases such as lupus vulgaris. And Professor Messer, which is considered today the father of photobiomodulation, received the scientific doctorate award by the Hungarian Academy of Sciences as early as 1965. So this is not new. It's just that for some reason we decided to take a pharmacological approach to everything, and we kind of forgot the simplicity that Einstein so often tried to show humanity, that we should be looking for the simple before we look for the complex. Now, let's look at the Earth's solar irradiance. If you think about when you look at this graph, this is what the wavelengths that the light from the sun irradiates over the Earth. Now, when you think about this, of course, over a period of evolution, you would imagine that there would be some adaptation and dependence of human cells to the light itself. And what is coming out recently, which is showed in a recent paper that I would love to show you, is amazing and exciting. But before we go there, if you look at this infrared range of the spectrum, so the infrared, which is included in near infrared, we will be talking about, and infrared is a much wider range that we receive from our sun on the day-to-day than visible or the ultraviolet light that we talk about so much. The difference is that probably because the infrared we cannot see to the naked eye, then we kind of just ignore. The largest range of radiation that we receive on a daily basis, and I'm thinking about here the theory of evolution, okay? We adapt to our environment with everything. And we know that we are light dependent for production of of vitamin D, and for melanin, which protects the skin, and so on. So that's an obvious thing. But then we always thinking, okay, vitamin D, melanin. We think about ultraviolet light, and some new studies has been showing something really amazing that I would like to share with you guys. And let's look at this, the humans, this graph of this latest study in 2019. Human cells are actually been shown to be affected and kind of dependent on near-infrared radiation, exactly within the, like I said, the range, the wider range that we completely ignore. When you look at this graph, the black line is the near-infrared radiation, and the red line is the number of cells in the human body. So if you see a child, because I don't know how big this slide is for you, but if you see a child, as they build in their body, they growing, they of course multiplying their cells, the proportion of the number of cells as we grow and as into adulthood, and you look at that red line, and then into elderly, it follows the same pattern as the near infrared light curve. And if you look at the bottom lines, which the UV light or the visible light, they're much more insignificant when compared to near infrared light. So they want to see, but why is this showing that we are so dependent on near infrared light? So before we go there, let's look what's been happening with humans' exposure to near infrared light over the last centuries. If you look at the red light, the red graph is the near infrared, the blue is the visible. Okay, so in 1800, we used to be outdoors and campfires, when we used to be exposed basically 50%, according to this research, to outside light. And we received much more for that reason in near infrared light. Now, as the time passed and we reshaped our habits in modern society, when we started staying more indoors and dependent on incandescent lights or LED lights, our exposure got much less. In 1950s, we only had about 25% of outdoors exposure. So if you look at the near infrared exposure going right down as the time passes. And in 1990, we're down to 15% outdoors. And currently, the research showed that we are spending our time about 7% outdoors. So, and the light that we are using in our house basically gives no infrared. And then also here points to the infrared lights can penetrate, yes, but there are some, depending on the glass of the window being used, and more the windows, the glass we're using on our windows that would let the infrared light, near infrared lights go through, is also increasingly being more blocking this light. So basically what we're showing is that currently we are more exposed to visible light comparing to near infrared, which is kind of against the natural sunlight habitat that we developed over for centuries. Now, the good news is that we don't really need direct sunlight exposure to exposure to the sun to get the infrared lights, because the reflected light, they tend to reflect near infrared. So in certain environments, so when you think about the blue as in the ocean, the blue and as in the sky, or the blue, the green, especially the green in nature, It has very high levels of near infrared reflectance, and that can actually also work for us. But the go back to that point is, okay, how much are we spending indoors? So the point made here is, shouldn't we be spending more time, at least in nature, even if it's places that we don't get so much near infrared radiation, would have the reflected light. Now, why do we need this infrared radiation? So here's what I don't like reading slides, but I think this is very important for us to read. This is what they found. The total melatonin. Now, melatonin, everybody knows, oh, melatonin. I take melatonin to sleep. I know it's good for my circadian. I need melatonin to sleep. But what they found that the melatonin that when we're sleeping, which is produced by the pineal gland, is only about 5% of the melatonin storage that we have in our body and that we produced in our body. 95% of this melatonin, and you see how the other side of this melatonin is produced by near infrared exposure. So let's read this. Mitochondria produce melatonin in many cells. Inside the cells, we're not talking now about the pineal gland in the brain in the night. In quantities, in order that magnitude of higher than those produced in the pineal gland. This subcellular melatonin does not necessarily fluctuate with the circadian system, but instead it is proposed to be consumed locally in response to free radical density within each cell. So it's like we have a bank of melatonin that we produce, the melatonin we produce in the day through our cells by being exposed to near infrared light, and that bank works as an antioxidant. This antioxidant will work in response to free radicals. That amounts for 95% production by the mitochondria. The near-infrared portion of natural sunlight stimulates an excess of antioxidants, which is this melatonin, in each of our health cells. So it's not like it's not just the skin. We remember near-infrared can penetrate the body. And it goes right to the cell, into the mitochondria, and there is where it stimulates the production of this melatonin, which works as an antioxidant reservoir to enhance the body's ability to rapidly and locally deal with changing conditions throughout the day. So we have an inflammation, we have a trauma, we have an injury or whatever, and all the toxins that we digest, we got to get rid of all these antioxidants that's being produced all the time. And this is what this reservoir is for. The role of the circulatory melatonin produced, the role of the circulatory produced by the pineal gland, on the other hand, is to provide an efficient method of delivering supplemental melatonin during periods of low activity or low solar stimulus to damaged or aging cells in both diurnal and nocturnal animals. So basically what he's saying here is the major reservoir is actually made of melatonin, which is an antioxidant that fights damaged and aging cells, is produced during the day by the near infrared. And what they're finding is that the night production by the pineal gland when we're sleeping is like kind of secondary, because it's only 5%. 95% is produced in the day. And this is a method that is used because there are animals that sleep in the day and stay up in the night when you don't have the infrared. And that's probably over time, evolution has made a way that these nocturnal animals can also produce this so important substance to combat the free radicals. while circulatory melatonin, which is this one produced by the pineal gland, may be the hormone of darkness, the subcellular melatonin may be the hormone of daylight. That was their conclusion. Now, if you look here, that's the pineal gland melatonin, which we saw is about 5% in production in the human body, and the 95% of production of the melatonin during the sunlight. They work, if you look on the right hand corner here, they work as antioxidants to reduce the reactive oxygen species, which is like free radicals. Okay. Now, oxidative stress-induced dysfunctions can be mitigated by photobiomodulation therapy. So I'll just briefly, I won't go through this. Like I said, I want to keep this very practical, and I want you just to have a think about an overall on how you should be thinking about light in your life. But the basic mechanism of action on how photobiomodulation or light in general of a specific wavelength. Of course, we have an optical window. That's why we make light of specific frequency or wavelengths. They will act actually simultaneously in different photoreceptors. But the current thought is, current find is that we have photoreceptors in different areas of our body, cell body. So some photoreceptors, which are the chromophores, we say, that's the thing that absorbs the light and use that light to produce this chain reaction of activity. We find them inside the mitochondria, which is inside the cell, which is the little engine machine that makes our ATP, our energy, and all those factors that's important for healing, for immune response, and for pain relief and everything. So the mitochondria basically is the little fuel machine. Now, there is a particular receptor there called the cytochrome C oxidase, and part of this light, or especially certain frequencies, are absorbed there, and we influence that pathway, which is being called the performance pathway, because that pathway is responsible for producing ATP, which is our fuel. So that's one location of the photoreception. The other is on the cell membrane itself, and the cell membrane, when is received, is absorbing that photoreceptor, is absorbing that light. It can work with the ion channels and many receptors there, especially one that's been pointed out recently was the neuronal pain receptor. And that's why photobiomodulation is capable of disrupting this neuronal pain conduction at that level and produce analgesia. That's how it kind of stops pain. And that's what we call the analgesic pathway. And then you have the extracellular matrix between the cells. Now we also have receptors, and those mainly, one of the major receptors that's been found to be very relevant there is the growth factor TGF-beta1 receptor, which is responsible for tissue regeneration. So they call that a regenerative pathway. I like to say a lot about the mitochondria pathway for tissue repair, for instance, especially for us. In fact, we use all of them in tissue regeneration in the clinic. But let's make an example. When you have you shine the light and you get the light, light needs to be absorbed to have an effect. This will influence the gene expression and the production of growth factors and the extracellular matrix deposition, enzymes, hormones secretion. That will induce new cell proliferation and migration and differentiation towards healing. So what is happening there is not an anti-inflammatory, it's actually a modulation of the inflammatory process. We are modulating. So if it's acute, we're modulating, so it's not too acute. If it's chronic, we'll bring it down to remodulate so it can go back to its pathway to reach wound healing. And with this, we have other factors with this pathway also, that is the release of substances like endorphins that's responsible for pain. So that's why we see, when we use photobiomodulation clinically, we see that we can speed tissue repair. We increase immune response of the host because we are also activating all these transcription factors, and we also induce pain relief. So I just want to make a parenthesis here. This is very valuable, especially now with this this question that's being raised, especially here in America, that we have so many people depend on opioids, and it's been shown that most of these patients, if I'm not wrong, it was 70-75%, start with a prescription drug, and then they go on into heavy opioids. And there is no need to be giving opioids in most cases in our clinic. We can use this photobiomodulation to modulate the inflammatory process, so it doesn't have to be as painful. It doesn't have to cause all that edema. It doesn't have, because it actually controls all that, controls edema, controls inflammation, and controls the pain. So by working with this nature or natural way of healing, we actually, which is scientific, we actually are allowing our patients to be less dependent on drugs. So let's now just jump straight into clinical considerations in photobiomodulation. I like to just point a few factors. Of course, it's very important when you're choosing your parameters, but there are some points that I don't see much people talking about, which, with my experience with photobiomodulation, I started with photobiomodulation in 1990. And over the years, not only reading about it, but with the clinical experience, I could see that very clearly. So I would like to share some of those with you. First, I want to remind you that you don't need as necessary to be a laser to do photobiomodulation. Why not? Because one of the properties, for instance, of a laser is the light to be coherent. But light coherence is lost within 50 micrometers of entering the tissue due to their optical properties. And coherence is not essential to produce a photochemical effect, which is what we are looking at in that cellular cascade that we talked about. And this was shown by Paul Young as early as 1989, and I was fortunate to work with him at the time in the UK. And the first therapeutic lasers were the helium-neon lasers, but that limited you to 632 nanometers. So now we have lights of wider, we are able to use light both in LEDs or as a laser for photobiomodulation in specific wavelength range, which gives us a bit more flexibility. Now, the other clinical thing I would like to point out is the skin type assessment before you treat. The skin is the main barrier to radiation. The majority of the radiation is scattered or is absorbed by the skin. The radiation barrier by the superficial layer of the skin is reduced as we go towards the infrared radiation, allowing greater penetration into the tissues. It will show you that. Now, let's look here. On your left, you have melanin-rich skin, which is skin of color or darker skin types, which like from skin type, let's say 5 or 6. And on the right, you have melanin deficient or just, in fact, it's like a lighter skin type 1, 2, 3, or 4. And you can see that when you're working with a laser or any light irradiation, the light, due to the properties and the melanin present on the skin surface, you have the a higher absorption rate by the skin in the rich melanin skin type. So darker skin will absorb more light. However, you to absorb it, but keep it in the surface of the skin. So that's why, let's say when we're working like with laser, high power laser or thermal lasers, we are very concerned about burns. So we use pulsing, we use cooling, or we use this low delivery mode. So you deliver low energy over a longer period of time. You got to be very careful with that skin. Only 20% of it is reflected. And when you're talking about light skin type and you're shining your light, most of it is reflected. 70% is reflected. However, 30% of it, which is actually absorbed, a larger amount of that absorbed light that went through, let's say, a lighter skin color person will go deeper than you will in a dark skin color person. So let's look, for instance, here was on a near infrared light. You can go as deep, it was shown to be go as deep as 80 centimeters. But look at that. You say, but the dark skinned person absorbed 80%. So it was a lot of absorption. So it's good. No.
but as you're pointing out, Dr. Aykroyd, it can maybe 80% absorb, but 20% still gets through. That's the key, right?
Yes. Okay.
And
yes.
that is what's making the difference. No. We're going to have to bring you back on your depth here is fantastic. And we want to bring you back on, but we got to get to some of the questions. So I know you're partway through your slides, but we got to bring you back on to complete this, because this is everybody stay tuned to part 2. Okay.
Okay.
So thank you.
Let me stop sharing.
Yeah, and we're just going to get into
sorry, I get a bit carried away, so I think I might be a bit
okay.
overtired.
All right, I'm going to right now just sorry, just give me a moment. This, come on. Okay, continue just for a moment, mentioning about the different wavelengths as far as penetration, and I'm just going to get this switched over here to make it all happen.
Do I need to continue?
Well, okay, you know what? I just got this working for us. So 1 second here. Go and turn on the video. Okay. I would like to talk right now. We're going to bring Dr. Aykroyd back on for the questions in a few minutes. But first, I'm just going to take a time just to introduce the products that we have. And then as we go forward, we would love to have your questions. Thank you, everybody, for joining us. And as Dr. Aykroyd was giving us details on how light can, what light can do and how light can penetrate. So I've been at it now for about 15 years. Started 18 years ago with, I know there's some dentists in our audience, and I developed one of the first devices with high power blue LED for the curing of the white fillings. So many people have gotten white fillings, and the blue light is the right wavelength to activate that. About 15 years ago, I developed a rather large PBM device. This had 5 optical watts of power coming out of it, which was pretty intense. And we were able to see with a pretty decent area, And we were just able to see over the years, many people improve from their various conditions. In the last 3 years now, we've brought out the SunPower LED Palm series. And this one in particular happens to be the classic. It has 260 LEDs, and it has 2,500 milliwatts of power. Then we go into the professional, and the professional, its price point is $975 US, and we do have that discount today to Monday. But this is has a considerable amount of light power coming from it, and what we've done is we have over 150 milliwatts per square centimeter coming out of this device, and we have the two different wavelengths. In this case, I'll just show you. We have with the professional model, we have the 660 nanometer, and there's the very large area, and I'll get into that in a minute. And then we have the 810 nanometer. Now you can just barely see it here. It's barely visible to the eyes, but the 810 nanometer actually penetrates deeper. Then we get into the Super Palm, the professional ultimate. The ultimate has about 25% more power. So that helps with a little bit depth, but it also helps with speeding up the treatment time. So you can deliver the joules faster to the area. And sometimes people are on the run, or if you're using it in an office or clinic, you want to try and keep the treatments as short as you can. Well, this saves you about 25% of the time. So either you can treat more areas, or you can get the patient flow through faster with a higher output. And then we have the latest model, still has the 660 nanometer. We call it the Super Palm 1050, and it has the 660 nanometer. And it also has right now you can actually see it on this camera, but I can't see it at all. And that's totally invisible, 1050 nanometer. And 1050 nanometer actually can penetrate deeper because of lower losses in the skin. So we have other models of lights. So even the one that you see behind me, that is the mini canopy. That mini canopy is about a foot square. So it covers a very large area, and it's equivalent to 15 of these palm lights in power. So 15 times the power of this, and 15 times the area. So that's what is accomplished by the mini canopy. And more recently, we've developed the helmet. And the helmet is another device that I'll just show you this way, has the two wavelengths. This is the 660 nanometer, and this is the 810 nanometer. So that just, I'm not doing a good job here, but that just goes like that. And that's how it is used. And we've had some successes with that. And we're working with multiple research places that are looking into how this light can be beneficial to a lot of people. So I'll just go over to the four key things. There's a lot of different PBM products out there, but the key is that you need to have the power to reach the depth and get the amount of energy that you want to into that area. So our key things is you would never be able to have that much light power out of a device with this amount without having usually a major amount of cooling fins on the back to try and keep the LEDs cool. And that would end up being very heavy. I have a patent pending on the way I'm cooling this. So this device ends up being very lightweight, even though it packs a lot of energy. So we have that. We also have the very large area. So instead of playing around with a little tiny flashlight to try and treat somewhere and spend several hours in the treatment, this is something that can treat in minutes to 10, 15 minutes, depending on the depth that you're trying to reach. So the other thing is we've got what we call the wall of light, which is the light can go very deep because it's such a large area. And even though they're scattering, as Dr. Aykroyd pointed out, that scattering still adds to the depth that we reach. And then the other thing is we can deliver 4 joules of energy in a very short amount of time. So we're basically looking at, in some cases, as short as 25 seconds on surface tissue. And we're looking at 158 milliwatts per square centimeter. And our newest kit on the block, as I said, is the 1050 nanometer. So the different price points is $975 for the professional. The ultimate is $1,300, and the Super Palm 1050 is $1,900. And we've got that extra bonus savings that you can have. So now what I'd like to do is bring in Dr. Aykroyd once more. All right, Dr. Aykroyd, could you talk, you did a little bit there in your video and or into your slides. You had mentioned that about the light penetration, and we had also talked about that. But do you want to explain again for one of our guests as far as the different wavelengths and penetrations, what kinds of things happen because of wavelength and because of power?
Right. Yes. I don't know if it was very clear, because that's part, I do go through that with my courses in a bit more depth. But basically, I don't know if it was clear to people, but basically when I was showing the electromagnetic radiation of light, we have the wavelength like from short waves, and it gets longer and longer and longer as you go towards the infrared, near infrared, infrared. So basically what happens when you are talking about short waves like UV light or visible light, you still on that, let's say that side of the spectrum, those lights, we tend to get a lot of scattering, and we don't tend to get much penetration within the deep tissue. So when we want to treat deeper tissues, normally we go to near infrared radiation. And that's when we're talking about the 1800 series. So 810, 1880, 940, 1050, depend on the wavelength that, 1040, depend on the wavelengths that you have available. But basically, those near infrared, as you enter the near infrared spectrum, those waves are longer and have a deeper penetration capacity. But there is another issue about penetration capacity that I like to talk about. Mm-hmm. And that's not just the wavelength, because it's been shown by the Monte Carlo model that when you have the size of the beam can influence the penetration. And I think yes, there, Tom, is where it would be good for you to develop later why your laser in particular can penetrate so deeply. So the size of the beam can influence. So if you have a larger beam, you can go deeper into the yes, tissues. Now, just I know you died to talk, but okay.
I'll just mention we had done some work on the early days with cancer at 635 nanometer, which we know is in the red spectrum is the poorest or poorer or definitely poorer penetration. What we did is we put tissue, considerable amount of pork breast tissue, which is very similar to woman's breast. And we had a very large area of the tissue that we had on top of plate. And we put the light was coming through from the bottom and going through the tissue. And we were able to measure on top of the tissue, the light penetration at a given point. And what we found is that we had on the upwards of as much as 6 centimeters penetration, 6 to 8 centimeters, actually went beyond 8 centimeters. But we were able to measure the light properties of the light going through that tissue, how much was left going through. And we just had the same light intensity, kind of like what we have with our devices, and we just kept increasing the area that we would have. We started with 1 centimeter by 1 centimeter, and then we went to 3 by 3, 5 by 5, 7 by 7, 10 by 10, 15 by 15 centimeters. And the interesting thing is we kept getting higher and higher amounts of light at a given depth as we kept increasing the area. So even when we went from 10 centimeters to 15 centimeters by 15 centimeters, we still saw a higher amount of light coming through. So the area, as you're mentioning, has a deep and profound effect on how much energy you can get at a given depth, even though scattering is taking place as with 630.
Right. So did you find a limit to, okay, up to so much, and then after that, as if I increase the area, I don't get any deeper?
Yes,
did you actually manage to get that far?
Yeah, we were able to significantly keep seeing increases as we went up to 10 centimeters by 10 centimeters. So that's about 4 inches by 4 inches, you know, as far as area. And once we went beyond that, we still got some increase, but it was minimal. You know, there was still an increase, but very little after that. So a 4-inch by 4-inch beam was still improving. So that's why the mini canopy is something ideal to help reach deeper. There's a question by David. David asks, does the Super Palm 1050 or any of the other sun power LED devices alter the circadian rhythm in any way? That's a very good question, by the way. The circadian rhythm is influenced by, they found new research that shows that there's a different spot in the eye that actually picks up wavelengths in the near blue range that actually affects the circadian rhythm. And that's in blue is 465 nanometer. We are far away in the red spectrum for influencing the circadian rhythm. And there's even some devices that are starting to show up that are used to have more red in your bedroom before you go to bed. I'm not so sure about that, but that's some new stuff that's happening. Maybe it influences people's attitudes. I don't know, but
I actually do that. I have red lights in my restroom and in my bedroom before I go to bed.
Yeah, so it's supposed to be helpful. And there's some newer research. So there's another question is, there was a mention of initial wavelength at 632 nanometer. Thank you, Dr. Witkoff. The initial wavelength of 632, that was specifically targeted for to activate a photosensitive drug for cancer applications. And your light is 660. What is the difference target tissue and application? So yeah, the 632 was specifically made to photoactivate the drug. And it's just like with dentistry, you have to have the exact wavelength as far as, or a very close wavelength to accomplish the task. In this case, for the photoactivation of this one compound, you need to be in the 630, the compound is delta aminoleucolic acid, or 5-ALA for short, but the 630 nanometer range is what we have to use. I wished we could use 660 nanometer like these palm devices, because then we could penetrate deeper and still reach the compound that's created, the porphyrins in the target tissue. But in this case, we have to have the right wavelength. I have from Francis. Thank you, Dr. Aykroyd, for this information. Please may I ask you if you have used oxygen therapy or any combination with PBM for your patients?
Actually, yes. I have used some ozone therapy. Okay. For healing and all that, and the pathway seems to be very similar. The mechanism of action of the ozone with the free radicals and all those chain reactions, which is very interesting. But my experience is mainly with light.
Okay, So there's a question about from John about when treating the head brain, how much light does hair absorb? And it depends on the color, depends on the thickness. And I understand from one of the researchers that they were able to show that if you actually wet the hair, you can improve the transmission. I haven't tested that myself, but it's something that is, so that's one thing is the hair. The second thing is it still can penetrate the hair. We have animals that have been helped with shining the light on their fur and still getting treatment with PBM for hips and other joint issues. So can the light penetrate the hair? Yes, it can. Is it reduced? Yes, it is a bit. But go ahead.
I can add it to that because actually I think I have a slide on this. Professor Humbling from Harvard did a lot of research on transcranial with photobiomodulation. And basically the issue about the hair is going to absorb or not. When we are above, say, 940 or nanometers, you are on the longer near infrared, when you're in the longer waves, you're not so much worried about the dark chromophores. And you're probably thinking about the hair, because of course the wavelengths, 800, 900, is absorbed by the darkness of the hair. But as you go further in the infrared, then the pigment is not an issue anymore. And right. I think that was his question.
Yes.
So,
yes.
So the light then is very knowledgeable. It goes straight to its target. And if it's absorbed by whatever, that is going to go there. And if it's not absorbed by that pigment, and that complements what you just said earlier, why we use 632. So really depends on the chromophore. It's the same when we're doing the light curing. Depend on the chromophore that was put inside that composite. Yes. And as I was in a conference, in a discussion one time actually it was in Canada. And they were discussing about, they don't disclose the manufacturer of the composite. They don't disclose the chromophores that they use. I think it was camphor quinone or something. That
yes.
Of this specific wavelengths. Yeah. And because you can optimize that. And if you have the correct wavelength, perfect for that particular chromophore, you can use less power. And
yes.
Because you know what I mean? And it's all about chromophore. It's all about the receptors.
The other one is that some people have asked me many times, they think that bone will stop light from penetrating through because it's hard. In actual fact, light there at the wavelengths we're talking about between 660 and 1050 nanometer can penetrate bone very easily. So it's actually in our research, we found out that light can penetrate the skull or bone easier than it can breast tissue. And we've been able to show at 635 nanometer even, we were able to go through 11 centimeter diameter breast. So we were able to get enough light, 5.5 centimeters into the center for a half-hour treatment for activating the compound. And we're still in research. We want to see this happen, move forward. But anyways, so there's a question here on from Sunny about, I'm not familiar with this. It's called first bite syndrome. Do you know about that, Dr. Aykroyd?
First bite syndrome?
Yeah, okay, we don't know, but you know what?
But what's the question about?
Yeah, if you just said any suggestion for this particular
it's funny you're saying this. I think I just read something last week. I forgot completely what it was about. If he elaborates, I'll probably but
yeah, well, you can send us an email. Go to Sunpower LED and send us an email, and we'll make sure we try and find that out. Another question, would it be proactive to use NIR on healthy breast tissue? And you know, thank you, Joy. Turns out that a lot of issues that come up are because of poor, whether it's poor blood circulation in different parts of the body, or it could be the lymphatic system is not flowing properly. And PBM has been tremendously helpful in helping the lymphatic system and the blood to flow. So those things are all very good in promoting good, not only skin health, but deeper tissue health, especially with the wavelengths of 660 nanometer to 1050. Okay, let's see if there's, I think we're going to be wrapping up our questions here. Okay, I would like to announce Patricia Casati. If you can send us an email to confirm that you're there and you're still listening, but we congratulate you for this. Dr. Aykroyd, I want to thank you very, very much. And I would like to have you back on because you had so much information there that I'd like to have a part B. And
I was going to say that. Why don't we do part B? Then we pick up where we.
Yeah. Okay. Great. Great. And please send your emails to info@sunpowerled.com, and we will we'll try and find the answers for you. As well, if you go to our website, and we have the different units there under shop. You can just click on the different whichever unit you'd like to purchase, and you can place through a credit card order. If you have any challenges in trying to put in the credit card information, please contact us as well through the email info@sunpowerled.com. So I want to thank you, Dr. Aykroyd. Thank you, everybody else, for joining in. And we hope to keep bringing very, very sharp, very knowledgeable people onto this program so that everybody out there can learn how fantastic PBM is and how it can help all different kinds of conditions in the body. So thank you, everyone. Have a great day, and bye for now.
Thank you. Thank you for having me.
You're welcome. And it's been a pleasure.